Question 4, we're to define each of the following terms. So specific heat capacity and heat capacity. So for 3 marks, specific heat capacity is the amount of heat energy required to change the temperature of 1 kilogram of a substance or object by 1 Kelvin. For 2 marks, heat capacity is the amount of heat energy required to change the temperature of a substance or object by 1 Kelvin. So specific heat capacity is for every kilogram, meanwhile heat capacity is just for the entire object altogether. And next, we're to write the formula to show the relationship between the specific heat capacity, small c, and the heat capacity, big C, of a body. This is a question that has come up multiple times on multiple exam papers. It is simply big C is equals to m times the little c. Heat capacity is equal to mass times specific heat capacity. Then, using the data on page 14, which you see to the right of the screen, you're to calculate the specific heat capacity of the metal, stating any assumptions made. So, looking at that apparatus and reading the question, we are told that some students were asked to carry out an experiment to determine the specific heat capacity of a metal. They used the apparatus shown in figure 5. So there's a thermometer, there's a low voltage supply, there's a metal block, insulation, and heater. So we're told that the switch was closed for a time interval of 900 seconds and the following readings were obtained. The mass of the metal block was 5 kilograms. The change in temperature was 50 degrees Celsius. The ammeter reading was 8.5 amperes and the voltmeter reading was 12 volts. So for 9 marks, we're to calculate the specific heat capacity of the metal. So, first thing we need to do is to determine how much energy was used. And in order to do that, we have to first calculate what is the power of the low voltage supply. So power is equal to current times voltage, or P equals IV. The current was stated as 8.5 amperes and the voltage is 12 volts. So 8.5 amperes multiplied by 12 volts gives us that the power was 102 watts. Next, the energy is equal to power multiplied by time. So we calculated that the power is 102 watts and the question states that the time taken was 900 seconds. So that gives us an energy of 91,800 joules. Now when it comes to specific heat capacity, we use our formula C is equals to heat energy divided by mass times the change in temperature. So the energy calculated is 91,800 joules. The mass is stated as 5 kilograms and the change in temperature is stated as 50 degrees Celsius. Performing this calculation with our calculators, we get that the specific heat capacity of the metal is 367 joules per kilogram degrees Celsius. What assumption did we make in this problem? Well, an assumption was made that no heat was lost to the surroundings.